Since I started a second video, I thought I'd go back to problems 11 and 12 before I move on to the last couple of problems. So again, I mentioned about orientation. I think it's extremely important if you think about when you're drawing pictures so orientation is done correctly. We definitely have two right angles in the quadrilateral SRQP, which appears to be a trapezoid. We definitely have the double arc measurement and then the single arc measurement. So the single is the P, the double is the S, and so if I'm going across the top, that would make this top one be an R and the bottom would be a Q. We're looking for X, which is QP, and we're told the height, which is 0.7, and we're also told that SR is also 0.7. So one of the comments I made is that you got to really make sure that you have a pair. So when you set the proportion, you definitely have a pair of sides that are completed, and then you're looking for the X, which is on the bottom, and so that gets paired up with the number that's also on the bottom. So the four numbers we're going to be using are going to be the 1.4 from the top over the 0.7 from the bottom, and then you set the second proportion up again using the X and its corresponding side. Again, making sure that the X and its corresponding side are placed in the right location, and then solve the problem from there. In the second problem 12, definitely these are the two numbers that are the corresponding sides based on the angle measurements, and then the 0.2, 0.5, and the 6x are definitely the corresponding sides. So if I would circle instead of triangle on the left, I could definitely make sure those are my bottom numbers, and then make sure my numerators I'm pairing up the correct sides between 2.5 and 7.5, and finish off the proportion. In problems 13 and 14, we're actually doing the side splitter rule here. So we're telling you that DB is 24. They're telling you that AE is 3. EC is 18, and they're asking for the length of X. So this is a perfect side splitter problem from our discussion from a couple of days ago. So the proportion would be the left side compared to the right side, and then I'm trying to figure out what the length of X has to be to make the side splitter ratios the same scale factor. Same thing for 14, the DE is 30. AE is 12, AB is 18, and then I'm looking for BC. So I'm setting the problem the same way, kind of a side splitter idea. So the AD got split into two pieces, AC got split into two pieces. That's what we made a side splitter. And so I'm going away from point A, the 12 goes to the 30, and I'll leave the second one for you to figure out. But they're both starting from point A heading towards the bottom shape, towards D and C. Set the proportion, and then cross multiply and solve for Y. And then the last problem, are these rectangles similar? And again, it's all about scale factors. So the 7 and the 6 are the two longest sides of the first of the rectangles, and the 6 and the 5 are the shortest sides. So if the answer is yes, they are similar, then the corresponding side should have the same scale factor. And if the answer is no, then it's because they don't have the same scale factor. We looked at a similar one like this a couple of handouts ago, that by just simply reducing the sides, both corresponding sides by 4, didn't create rectangles that were similar to each other because the scale factor ended up being different. So angles, sometimes with quadrilateral angles, it's not always enough. We have to not only check angles but also scale factor. Where triangles, actually having the angles is enough, like angle. So hopefully that's enough information for you to reflect on the work you've done, or be able to finish off the problems that you were unable to start.